So I'm Matthew. I'm Chris.
I'm Herb.
I'm Neetu.
I'm Gemma.
Okay, and Elizabeth unfortunately had to leave early, but our project is exploring the implementation of drones for mosquito population control, a problem that I'm sure you're all too familiar with.
Do you have any fears of animals in this world? Such as sharks, snakes, or even mosquitoes? Well, you should be scared of mosquitoes, because they're the deadliest animal in the world. According to Bill Gates, they've killed 750,000 people every year. They do this by carrying diseases. Diseases include dengue fever, malaria, and West Nile virus. Currently, we're not combating this very well. What we're doing right now is aerial spraying, which is using planes to cover a large area with spraying, and residential areas. What we're doing is using trucks to go up and down streets and just spraying pesticides into the air, such as in my town. So these are ineffective because they're not really targeting specific areas of where they breed, which is still areas of water. And also, even worse, they expose humans and animals alike to pesticides.
Thank you, Herb. Now, what's the solution to this problem? We propose to use drones that locate the mosquito breeding grounds and spread the pesticide. Our work is in collaboration with the Rutgers Vector Biology Department. Our team then decided to actually construct an actual drone like a quadcopter. This drone has 3 targets. The first being that it would survey a plot of land and using live streaming. And this can be achieved by there's a camera system on the quadcopter, and the second one is to actually locate the breeding grounds using image processing. And the last one is to spread the pesticide by marking the points like on a map and having another drone coming and spraying it. And here's a pictorial, and this shows how the 3 targets can be achieved. This is the quadcopter. It has a GPS system and a video camera for live streaming and locating the sites, and it's connected to a system that receives the images, and from these images we can actually find where the mosquitoes are and spray the pesticides. I'll pass it on to Chris, who will talk about the challenges.
So within our project, we recognize 2 challenges. So currently, it is rather difficult for drones to not only locate these breeding sites of mosquitoes, but to also stay and fly for an extended amount of time. So of course, being government and scholars, we strove not to just address one of these challenges, but both. So with regards to, sorry, I should change the slide. So with regards to actually locating these breeding sites, we recognize the fact that mosquitoes like to breed around stagnant water. So our team wanted to make use of what is known as the albedo effect. So albedo is essentially a reflective coefficient of diffuse reflectivity. So what the heck does that mean? So in layman's terms, basically, we have an incoming light transmitted, and we have light that's reflected. So albedo is your ratio between your light transmitted and your light reflected. So therefore, to exemplify, fresh snow has an albedo of nearly 1. Whereas something like a black body that reflects no light has an albedo of 0. So using a high-definition camera that we mounted on our quadcopter, we would take pictures of numerous sites from an aerial view, and we would analyze the albedo, because water has a very distinct albedo relative to the surrounding ambient conditions. With regards to overcoming flight time, well, many of you have smartphones. We know that they die after a long period of time due to apps. So just imagine how long a quadcopter would fly. So we want to make use of the vibrations within our quadcopter, and the way we accomplish this is using something called piezoelectric materials. Piezoelectricity is a phenomenon where we can take mechanical energy, mechanical stress, and we can convert it now into electricity. And we wanted to attempt to use these piezoelectric membranes to convert the stressors into electricity that we use to extend our flight time. So if our quadcopter can be considered analogous to a human body, the brain would be our autopilot 2.6. This controls most of the components on our quadcopter. It's located there on the center of the quadcopter. Therefore, then our, I guess you could say, legs would be our propeller motors. These spin at a really high revolution rate, and this ensures that our quadcopters can actually fly. Our eyes would be our pulse cam HD camera, which can take really good shots. We'll show those later. And our body would be a fiberglass frame, which is extremely light and durable.
Okay, so now one of the major benefits of our drone specifically is the ability to fly autonomously. So flying autonomously means that the drone can fly by itself with the press of a button. So with this ability, we can simply use a software over there called Mission Planner to simply press a button and the drone can fly by itself over the area that it needs to fly over. Now this is very beneficial because for farmers or whoever's spraying pesticide, instead of flying it manually with a controller, which is very annoying, it takes a lot of time, they can simply sit there, lay back and press a button and the drone can fly by itself and do whatever it needs to do. And unfortunately the video isn't working right now, but on the next slide we have a picture instead. Okay, so the second major innovation that we performed on this drone was using image processing. So using this camera, we get a live video feed back to the computer, and using C++ and the OpenCV library, we were able to learn the OpenCV library and actually write code in C++ to process the video. And using this, we wrote a test program over here using different lasers. And as you can see on the left side, we have a green laser, and we wrote code to actually use the albedo effect, similar to up there, to blur out everything that wasn't what we wanted. And so we left out the green over there and all the colors over here, as you can see. And now in the future, we're planning on adding more features such as GPS coordinates, and as someone said before, we can actually map out where all the water bodies are. And in this picture over here, you can't see it very well, but on the top picture, where the black X and the yellow X combine, there's a water body right there. As you can see, it's very difficult to see, but for a drone using our image processing capabilities, it's very easy using the albedo effect, and as you can see over here, we have a binary graph of the colors that we're looking for.
Okay, so after a whole year's of work, we've created a working drone. We were able to receive images from the camera and send it to the computer. We were able to locate and set coordinates for a drone using the software program and our GPS. And we were able to analyze the surface and find the brightest points using the camera and the albedo effect. And then we were able to measure the frequency and voltage given off of the drone while in flight using the piezoelectric membranes. And overall, we were able to demonstrate a novel approach to solving a real-world problem, something that happens in New Jersey that we have to worry about. And in the future, we hope to work more on communications between this drone and drones that actually send out the pesticide, and maybe investigate more in piezoelectric recharging of the battery. We'd like to thank STEM scholars for funding this, the research and development program, the vector biology for some of the components of this, and our parents for driving these guys around and learning to use them. All right, thank you very much, guys.